Hey everyone, this is Sean with Alexander Tutoring, and today we are going to talk about proofs in geometry, the most hated topic of all time. I hated proofs in high school. I don't hate them now. Now I like them. But here's why I think that most students across the board just don't like them. It's because unlike other things in math, there's no like set way to do them. Usually when you learn a math problem, we like it because there's one way to do it. You just do the steps, you get to the answer. It's the same every time. Proofs, there's like there's seemingly no procedure. It feels like you just got to figure it out from thin air, and it's not the same every time. So that's kind of true. However, there are some guidelines to follow that will be helpful that you can repeat every time that I want to give you in this video. Furthermore, there's an attachment to this email that's going to be your absolute best friend. It has all the theorems and postulates you could ever want all in one place. One thing that I've always found very annoying is that in a lot of these geometry books, the theorems and postulates are scattered about the chapter or multiple chapters. So you end up like flipping through the book trying to find the right one. So it's really helpful to have them all in one place. So check out that attachment to the email. It does have them all in one place. So here's an example proof, and I'm going to give you an example of how this procedure goes. The first thing we do, we always do this kind of column thing with statements and reasons. Okay, here's the good news. You always know the first and last step. The first step is always what's given. In this case, AC, the line segment AC equals the line segment BD. And the reason is that it's given. And you always know the last step. It's always got to end with what it is you're trying to prove. So I'll stick that at the bottom. The line segment AB equals CD. Okay, now the trick, of course, is just to figure out what goes in the middle. All right, so now we want to start thinking about the problem. So what do we have here? We know that AB, AC from the given, that's this segment, is equal to the line segment BD, or this guy. So picture, you always want to have a picture. Okay, and now what are we trying to prove? We want to prove that this guy is the same length as this guy. Okay, now we want to start thinking about how we might go about this and what postulates or theorems might be useful in this case. You do not have to see it all the way through the beginning. I do not see this through all the way to the beginning. A lot of students get paralyzed because they feel like they have to know what it is, see the whole problem all the way through before they start. That's not how it works in math. You think about the problem and just start, even though you don't see it all the way through, and learn to trust yourself that you're going to get to the right answer. Even if you don't get to the right answer, it's all about just starting. Okay, so what do I see here? I see these two segments, right? And then we want to get to the green section, and we can see that, like, for example, AD is the sum of AB plus BC plus CD, right? And so now I'm starting to think about segment addition or subtraction. And so I'm just going to start writing things down that we can figure out from this. So what, for example, I could say, let's add some of these guys together. Um, so AC, what's AC? And again, I'm actually pulling this from the given. Can we write AC in terms of the sum of some smaller segments? And of course we can. We can see pretty simply that that's AB plus BC. Yeah, cool. Let's look at the other side of the given, BD. What's that equal to? That's BC plus CD. Okay, and the reason, again, that we go look at that attachment, but that's the segment addition postulate. Okay, now what can we do with those? We'll look at our given. We know those are equal, right? AC equals BD, AC, BD. So we can set these two guys equal to each other. Let's do that. Oops. What did I use there? That's the transitive property, which you must know. That's one of the most commonly used, excuse me, one of the most commonly used reasons when we do these proofs. And just down at the bottom here, just to recall, what the transitive property says is that if A equals C and B equals C, then A equals B, which is the most logical thing in the world. But in geometry proofs, you really have to have a reason for everything. So that's called the transitive property. Definitely know that one, that you're going to use that one all the time. Really, it's just substitution, right? We're setting things equal to each other. Now check this out. There's a BC common to both sides of the equation. Well, if you think of it like an algebra equation, what happens? They cancel, or what's really happening? Well, if you think about it as subtracting BC from both sides, subtraction, right? That's what you do in algebra. What do we get? We get what we're trying to prove. Yay, AB is congruent to CD. So now I have to justify, I subtracted BC from both sides. That's a subtraction property of equality. Same as canceling is really in this case, you're subtracting from both sides. And we arrive at what it is we are trying to prove, QED. What does QED mean, in case you're curious? You see that at the end of proofs. It's actually Latin for quo eris demonstratum, that which was to be demonstrated. Okay, I hope this procedure is useful to you when you do your proofs. Again, the attachment that I gave on this email is your best friend. That's really going to help you. So good luck. Definitely hit me up if you have any questions. All right, take care.